Hello everyone, I'm Titan Shay, a product leader for QNAP, and with me today is David Zhang, a product manager for Apacer.
Hi Titan, hello everyone. It's a pleasure to join you for this webinar.
My pleasure too. Today we'll be talking about QNAP Virtual Network and Apacer value-added innovation and how we bring them together to accelerate digital transformation. Let's take a look at our agenda for today. I will be discussing some challenges facing digital transformation. I will moving on to introduction QNAP software-defined platform and how it can help. Then David will talk about Apacer value-added technology that also work to solve transition issue, and we will close with the short summary. As the pandemic spread around the world and changed the work style of the business everywhere, we start to hear similar stories from our customer. We want to transition to a digital environment, they said. But it's not as simple as we thought. Unexpected issues during the system update keep popping up and slow things down. People in our industrial are getting attacked by hackers. If our devices crash and show a blue screen of death to our customers, it's hurt our branding awareness. Not everyone experienced all those problems, but they are aware of them and want to avoid them. QNAP set out to solve a specific problem. We heard from customers who had become our complete digital network for their devices. But when they want to roll out to a software update, 5 to 10% of their devices will be unable to run it. Then they did need to take the whole network down while the engineer worked on those devices. One by one, they did get them up and running again, but they could only get the network back online once all problem had been solved. This led to unexpected amount of downtime. Our team set out to find a way to solve this, and after experimentation and deployment, we finally came up with the solution. It's called the QNEOS and is run on our QCP hardware platform. The way it works is simple. For every device that is connected to a network, our solution virtualizes all the physical devices on your network. The result is a virtual copy of the entire network in same devices at the same time. When it's time to push a new service update, the admins will send it to the virtual copy of the network first. If a few devices fail to update properly, the engineer can work on them, revert them to a previous version, or do whatever they need to do. The key here is that those is all happening only in the software copy without editing new devices. The real network is still running on the old OS, and the production isn't held for a moment, no downtime at all. So, when the engineer have management to resolve all the small specific issue with the system update, they can push it to the virtual network and will see it all running smoothly. Only then do they send it to the hardware. Since the hardware is identical to the virtual network, the software update will roll out correctly and the production facility will never be taken offline. Our customer really appreciate the differences this make. And once they know they have this system on their site, the decision to transition to a digital network is a lot easier to make. Let's take a close look at the Qnap Solution. It's including 3 major components. The QCP, a hardware platform that including a high-performance CPU and a smart NIC card. It supports hardware isolation technology, such as SRLV, DBDK, and QAT. QNE, an operation system deployed by QNAP, building VM and container capability, It supports Windows and the Linux-based application server, and also support virtual network function from others. Could be open source such as LouderOS, pfSense, Suricata, or even the VNF from other vendors such as Fortinet, Parado, can be running on top of the QA operation systems. We also provide the visualization topology tools to allow you to connect all your software-defined service in one single topology in any configuration you want. Amid Cloud, it allows you to management, deploy, troubleshooting all of your VM and container-based servers in one single cloud platform. And of course, it's including all the information that you need to operate your hardware QCPE. Providing a robust and high-performance hardware platform is the foundation that makes this system successful. Lots of challenges can appear when all different servers are running on the same hardware. As a solution provider, we have to understand what is the detailed behavior of each hardware component to make sure we are not overrun, and also maximize the performance for individual objectives at the same time. We are glad to work with Apacer to help us to understand the detailed behavior of the hard drives when we are running multiple services on top of them. It gives us a clear picture of how systems work with hard drives and avoids it become a weak point of a hardware system. Is one step that further helps QNAP to provide a more reliable hardware platform. My colleagues at Apacer have also deployed some technology that make the digital translation easier. Davey, could you tell us a bit about those?
Thanks, Titan. I think we all have a clearer understanding of QNAP's QECPE solution now. Today, I'll be talking about the technologies Apacer has developed to optimize drives to extend PE cycles, as well as to protect storage devices and network from hackers or unexpected crashes. There are three technologies that we'd like to present to you today. The first one is called SLC Lite X. This is developed to face write-intensive workload by greatly increasing SSD's endurance up to 100K PE cycles. The second one is signed firmware. With this technology, Apacer's SSD can protect its own firmware integrity without the risk of being manipulated by cyber attacks. The third one is our cloud series with core Snapshot technology. This feature supports remote management and backup recovery mechanisms. Without further ado, let's get into the first topic, SLC Lite X. As a brief introduction, I'd like to give you some fundamental information about how flash works. NAND flash characteristics is erase before write, and PE is the abbreviation for program erase. This means the time of erase-write cycles each cell can endure. First one is SLC, as known as a single-level cell. This chip stores 1 bit of data per cell, offers extremely high reliability and 60K PE endurance, but is much smaller in overall capacity. Next one is MLC, as known as multi-level cell. It stores 2 bits of data per cell, offers twice as much capacity compared to SLC, is much lower in pricing, and offers 3K PE cycles. The last one is TLC, as known as triple-level cell. TLC stores 3 bits of data per cell, is lowest in pricing, largest in density, and is now widely adopted in consumer markets. PE cycles are ranged from 500 to 1,000 times. This page mainly describes 2D NAND flash. Next page, we will start to introduce 3D NAND and how our SLC Lite X technology works. Our SLC Lite X is based on 3D NAND technology, and the central concept is to make 3D TLC behave like SLC. By doing so, only 1/3 of capacity is accessible to users. The other 2/3 of physical capacity will be utilized by firmware algorithms for data placements, background handling, and performance improvements. Therefore, cell distribution management for 3D TLC is necessary in order to greatly adjust the voltage delta and charge sensing. The firmware is carefully tweaked by Apacer's engineering team to offer the greatest numbers of PE cycles in this format, 100,000. Which is 33 times more than an MLC or industrial 3D TLC. And how did we achieve this significant improvement? We chose industrial-grade 3D TLC and picked out the highest quality of NAND flash. Then our engineering team optimized firmware structure along with enhanced ECC handling algorithms to achieve this success. While our competitors are offering 30K PE for similar technology, we have surpassed everyone else and offer the highest endurance there is, 100K PE. The advantages of SLC like X is obvious. Endurance is 33 times more as compared to conventional 3D TLC, while cost is down 86 to 92% as compared to SLC. Now, users will be able to purchase an SSD which has the best cost-performance ratio. Our second feature is signed firmware. Signed firmware is a protective mechanism on the authenticity of firmware package. There are some applications that are very sensitive not only with data, but with backdoors and viruses as well. Signed firmware encrypts itself with a special algorithm. If any modifications are made to the firmware contents, SSD will not be able to function any longer. So how does it work? When Apacer develops a new model that supports signed firmware, first step is to create firmware raw data and generate a private key. The next step is to use third generation SHA-256, which is secured hash algorithms to encrypt firmware's raw data, and simultaneously using private key to generate another public key. Third step is to combine firmware hash code with private key's prime number to create a digital signature. Public key will also generate a set of hash code on its own. Fourth step is to integrate firmware hash, public key hash, and a digital signature and turn them into a complete firmware package so that we can load it into our SSD. If user wants to perform firmware upgrade, they will receive a new firmware from Apacer, which is already signed. The first process is to decrypt 2 sets of hash codes in order to retrieve public key and original firmware data. Second step is to compare public key with the digital signature that has already been stored in Apacer's SSD. Once confirmed matched, new firmware can now be loaded to SSD. If firmware package was tampered by hackers doing web transfer, the original hash value will be changed. It can no longer match the original digital signature stored in the SSD, thus leading firmware update to failure, preventing viruses or backdoors planted by hacker. Last technology for today is Cloud Series with Core Snapshot. Before talking about the mechanisms of Core Snapshot, we must mention about remote management. Apacer developed a model called SV25C for cloud management, and it has client version and cloud version. Client version allows customer to operate on local site, which means their application is physically accessible at a close range. Cloud version is for those applications that are far away, and user can read SSD status or send specific commands to SSD via internet. It allows user to monitor and analyze SSD in a remote range, and sending notifications to user upon specific settings. With the flexibility of operating near and far, Core Snapshot provides the possibility of backup and recovery with one single button press or mouse click. Although there are thousands of different applications, we can all narrow down to a simple behavior. Actual application to server, regardless of gateway or privacy server, and then server to data center or cloud. Our remote management solution will be able to monitor and analyze the health status and workload of an actual application via cloud and notify our user upon specific settings. Apacer has a premium software package. It's called a Double Barrel Solution. It consists of 2 programs, Core Analyzer 2 and SSD Widget 2.0. Core Analyzer 2 is a software that can analyze application workload by analyzing the commands SSD have received. And SSD Widget 2.0 can monitor your SSD's health status. With these 2 software programs, user can know their applications from head to toe and anticipate any potential risk in advance. Core Analyzer 2 is a very powerful tool developed by Apacer. It records SSD's behavior up to 7 days so we can trace back and understand how SSD was treated. And don't worry, none of the user data will be recorded. It only records command types. Users don't have to initialize anything. Core Analyzer will operate on its own when SSD is powered on. Once the log file is dumped by user, they can send it back to Apacer. We'll load it to our Core Analyzer, and it will be illustrated as the image you see now. Please know that this software will mainly be operated by Apacer's R&D and generate a report when workload is analyzed. User will use another utility to dump the log files. In host behavior, user will be able to see total command read-write percentage, total sector read-write percentage, and the counts of total idle, standby, flush, or trim. This can help us judging whether platform behavior is write intensive read intensive, or not critical at all. Second tab is the access behavior. It shows the distribution of sequential or random access patterns, file size of read and write, and whether files are 4K aligned. Third tab is operation behavior. This page indicates the SSD's health status. It shows the increasing curve of average erase counts, total power cycle counts, and thermal history. These three factors can greatly influence SSD's lifespan, which is why we thought it's essential to keep track. After seeing how to analyze workload, here's how you can monitor your SSDs. In the first tab, you will see drive info in general, model name, serial number, firmware version, health status, how many PE cycles it had used, etc. If you have multiple SSD installed, you can also select other drives from the pull-down menu located on the right side of this page. Next tab is Smart Info. This page shows error counts, later bad block counts, abnormal power counts, and other factors that might affect SSD's health. Smart attributes can also be customized upon request. For example, if customer wants to see total sector write or read, we can add another set of attribute to show in this page. This page is Disk Utility. It can sense special features and automatically change its icon to show corresponding functions. For example, if the drive support erase function, it will show secure erase. But the drive in this demo supports AES function and crypto scramble, which we call instant key change. This icon shows instant key change is dead. Dynamic workload is a feature for you to real-time monitor your SSD workload for the next 60 seconds. This comes handy if you need to know your SSD is constantly operating in the background. As mentioned previously, Core Analyzer is mainly operated by Apacer's R&D. But what if user wants to see their workloads as well? In our SSD widget, user can also have a glance at their workload summary for the past 7 days. Although it's not as detailed as the actual Core Analyzer, but most of the time, it's more than sufficient for our users. Remote Monitor is setting up a FTP for you to upload SSD status logs to a designated server. This is a very convenient way for users to summarize all of the drives that are implemented in the fields and check status altogether. Core Snapshot is a system disaster savior. It's highly compatible with all operating systems and can back up and subsequently recover not only an OS, but also all the data on the SSD. But what's most impressive is that it can carry out the entire recovery process in just 1 second. This can be triggered via various ways such as SSD widget, external button, or cloud portal.
Thanks for that, Davey. Now I see how Apacer value-added technologies can reduce the customers exposed to the hacker and unexpected crash.
They sure can. And I think it's clear now how QNAP and Apacer both work hard to make the customer's transition to a digital network easier, smoother, just plain hassle-free.
That's true, and with downtime minimized, thanks to those deployments, our client's factory and digital operations will be running smooth the whole time. It will make quite a difference to their bottom line.
Well, that's all the time we have for today.
It's been great to discuss those innovations with you, David. There's so much QNAP and Apacer can do for our customer, especially when we work together.
That is so right, Titan. Who knows what we'll come up with in the future, but that's a topic for another day. Thanks for joining us, everyone. Goodbye.
Goodbye.